Okay guys, today let's talk about how to perform the enamine mechanism. This mechanism is generally going to be found in the chapters involving aldehydes and ketones. It involves a secondary amine, which means a nitrogen attached to two R groups, and then it's going to react with the carbonyl of an aldehyde or ketone under acidic conditions. Now the acidic conditions just means if you need protons or if you need perhaps a base to remove a proton in the name of balancing charges and getting everything back to neutral and stable and happy, those acids and bases are out there, okay? The easiest way I found to learn this mechanism is by knowing what you're allowed to start with, what you're allowed to work with, and then have a general idea of what your finished product is supposed to look like. So that's gonna be an enamine when we're done. And on this mechanism page, I've taken the liberty of highlighting what I just mentioned. You're allowed to start with an aldehyde or ketone. You're going to use a secondary amine, and you've got acidic conditions as needed. So let's walk through this mechanism, and then we'll do an example. So here's our ketone, and the first thing we do is gonna have a nucleophilic attack by our secondary amine. So this nitrogen's lone pair is going to hit this carbonyl. It's gonna cause this to resonate up like that. We've created two charges now, one on top of this oxygen and one on this nitrogen. We're gonna try to get to a neutral halfway point, okay? So we're gonna protonate this and make it alcohol. So now we're getting rid of one charge. And then, so if HA represents some kind of acid, A with a lone pair represents the conjugate base of that acid, okay? So the conjugate base is then going to rob this secondary amine of a proton, and we're gonna get this nice neutral halfway point that we call a carbenolamine. The nice part about this mechanism is if you can get to the halfway point, you know, everything's neutral, you know you're on track and you're halfway done. And then just maybe compare this halfway point to your final answer. I don't see any alcohol or anything involving O in the final answer. So that probably means we're gonna focus on turning OH into a good leaving group by protonating it and making it water. So that's what's gonna happen in this next step. At the point we've turned OH into a good leaving group, we're gonna take the lone pair on nitrogen, resonate it down or up, kind of depending on how you're looking at it. This fifth bond that forms here is going to kick off this water molecule. And this is usually what we call the hydrolysis step, where you lose a water molecule. Then we get to this molecule here, and then here's where we're gonna be a little different from the imine mechanism. Our conjugate base is going to take off this proton here, and then the two electrons which make up that C to H covalent bond are going to be collapsed towards this carbonyl where there's a partial positive charge, because negatives like to go after positives. And that's going to form a double bond here, which then resonates this double bond up to form a lone pair on this nitrogen to make it neutral. And this is our final answer. This was just something I drew from a previous molecule. Let's walk through an example. Okay, so here is our secondary amine. And first thing we do is do this nucleophilic attack from the lone pair on nitrogen to the carbonyl. This thing is going to resonate up and become a third lone pair. So now we have this molecule here. O with 3 lone pairs, minus 1 formal charge. Draw these lone pairs here. And then we have this nitrogen, which is attached to 1 proton still, and then this carbon group like that. Then we're going to protonate this oxygen, take care of its charge, make it neutral, make it alcohol. Then we get to this molecule here. Still have a +1 formal charge on this nitrogen here. Then we are going to, I'm just going to abbreviate this deprotonation step, minus H+, because usually we get to do that once we get to Orgo 2. That's going to take us to our halfway point that's neutral. You've got your alcohol here, and then you have your NR2 group here, like that. I like to go ahead and box it in and let me know I'm halfway done. Then we're going to, OH makes a bad leaving group, so we turn it into a good one by protonating it, making it water. So that's what's going to happen next. So now we have this molecule here. Keep track of your charges, very important in each step. Single lone pair here completes oxygen's octet. +1 formal charge. And we have our nitrogen group still kind of hanging out like that. Then, similar to what we saw with the imine mechanism, nitrogen's lone pair is going to form a double bond here, and that's going to kick off this water molecule. We call this the hydrolysis step. My turkeys are talking today. So now I've got this molecule here. Double bound nitrogen here. Sorry for that being kind of crunched. +1 formal charge. Now, in the example, or in the case that you've got this part's asymmetric, you want to take as far as what we call this the left and the right, as far as which side to take a proton from. You're going to go with the one that ultimately would create the more stable alkene or double bond afterwards. So for that reason, we're going to take this proton over here off the right side, like this. Okay, and I'm going to do B with the lone pair to represent some conjugate base of whatever our acidic conditions was, okay, or were. So deprotonate, and then the 2 electrons, which did make up this C to H bond, they're going to kind of collapse like that, and then that's going to do this here. And then that brings us to our final molecule. Methyl group here, double bond here. Nitrogen is now single bound to that carbon. And we've restored neutrality to this molecule. And we're done. And that is what we call an enamine. If you found this video helpful, but you need more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogoat.com. And please like, comment, and subscribe to our YouTube page to help our videos find more students like you. Tell a friend. And if you're interested in private tutoring, or if you want to see a concept explained that you don't see on our YouTube page, shoot me an email, orgogoat@yahoo.com.